The instantaneous rate of change, abbreviated IROC, of a function f of x at the point x equals a is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. And in a picture, let's say this is our function f of x. This limit ends up being the slope of the tangent line at that point. So the slope of the tangent line when x is exactly equal to a. That's what this limit comes out to be. Let's do an example of finding instantaneous rate of change. Find the instantaneous rate of change of f of x equals x squared at the point x equals 3. So since we're looking at the point x equals 3, that means that 3 is our a value. And that means in the above function, the limit equation, we're going to write the limit as h goes to 0 of f of 3 plus h minus f of 3 over h. We'll find these two values separately, so find f of 3 plus h. That means 3 plus h squared, which means 3 plus h multiplied by 3 plus h, which is 9 plus 3h plus 3h plus h squared, which is 9 plus 6h plus h squared. So this is f of 3 plus h. Now let's find f of 3. That is just 3 squared, which is 9. And now we plug those values into this limit formula. Limit h goes to 0, f of 3 plus h was 9 plus 6h plus h squared minus f of 3, so minus 9, all over h. Notice that if we try to evaluate this limit right now, we end up with divided by 0 if we plug in 0 for h, so we can't evaluate the limit yet. We want to simplify it. If you see, we have 9 and minus 9, which cancels to give us the limit h goes to 0 of 6h plus h squared over h. In the numerator, we can factor out an h. Limit h goes to 0 of h times 6 plus h over h. And then these h's cancel out. We get the limit h goes to 0 of 6 plus h. And at this point, we can plug in h equals 0 to the limit and get 6. So our instantaneous rate of change for this particular function is equal to 6.